Next topic is performance profiling using NetBeans profiler. So far we have covered the memory profiling using NetBeans profiler and the Eclipse memory analyzer, and now we are going to learn how we can profile performance, CPU performance using NetBeans profiler. So here we are going to talk about the concept of CPU profiling, and then we are going to look into various features of NetBeans CPU profiling, including profiling schemes, profiling points, and monitoring thread status, and then identifying performance bottlenecks using NetBeans CPU performance profiler. CPU profiling. So what is CPU profiling? So basically, CPU profiling provides information about where application is spending its time. It's basically profiling the execution performance. So the reason that you want to perform CPU profiling is these are the situations. Poor application throughput measured against the predefined target, performance target. Certainly when your application is not performing from throughput perspective, you want to actually find out what's going on. Saturated CPU utilization and high sys and kernel CPU utilization, high lock contention. And these are all situations where the performance will be impacted. Okay? So you can actually use the NetBeans CPU profiler, for that matter any profiler out there in the market, to find out what is going on, meaning where the application is spending its time. To a less extent, poor application scalability. I mean, scalability could be impacted by the performance as well. So strategies that you want to take for CPU profiling. So some profilers, such as NetBeans profiler we are using, allows you to profile a subset of an application. Okay. So in general, you do not want to profile the whole application because that could actually incur lots of overhead. Okay. So it might actually skew the performance data. Okay. Profile from, so typically what you want to do is you profile from a large suspected area, and then you drill down into smaller area as you get more information. Okay. Another approach is using what is called the dtrace script. These trace scripts are very powerful tools that was originally invented for Solaris platform. Now is being supported in Linux as well as a Mac OS. Okay, NetBeans profiler. So there are two profiling schemes supported by NetBeans. One is called the sampling, and the other one is called the instrumentation. So you have seen in our previous presentation of NetBeans profiler for memory profiling, sampling is called the quick, and instrumentation is called the advanced. Okay. So instrumentation profiling scheme has two schemes, two types. All methods are root methods. Okay, so we're going to talk about those things in the latter part of this particular slide. So sampling causes lower overhead, okay, because it's just samples. So on a periodic basis, because it's just a sampling, it's less precise than instrumentation. Okay, so if you need more precise data, then you want to perform instrumentation rather than sampling. So instrumentation, basically, it will instrument the methods of profile the application. So basically, it's inserting Java code to the profiled application during runtime. Now, all methods, if we choose all method instrumentation, then all methods of the application as well as the system classes are going to be instrumented. And usually, you do not want to do that. Okay. Instead, you want to use what is called the root method. So when you select the root method, that is a method that that is the method. That is the only method that will be instrumented. Okay, so only selected root methods are instrumented, and of course, it will cause less overhead than all methods. So in general, what you want to do is you want to instrument selected set of root methods, and also you do not want to instrument all system level classes, because those are not something that you can control. So only project classes. So root method as well as project classes only. I mean, those are the combinations typically you are going to use. You can also use filter to further down further narrow the scope of classes that you want to measure. Okay, so there are built-in filters such as profile all classes. Yeah, so this is again, you do not want to select this one in most cases because it incurs higher overhead and in many cases too much information. Okay. Profile only project classes and also use a root method. So these are the combination you typically want to use. You want to measure only project classes instead of the system classes, and only a set of selected root methods. Okay. You can also select project and sub-project classes. So if you happen to have a project that has a multiple sub-project, you can include sub-projects as part of the profiling process. Quick filter is actually something you can actually create your own filter. Okay, and you can also select exclude Java core classes. Okay, so Java utils or Java lang, those classes, something that you do not want to measure. Okay, so recommendation is detect basically sometimes you want to start with the sampling first to detect the suspected area. So, basically you get the sense of where things might be going wrong. And then you're going to use instrumentation scheme in smaller area. And then you also want to use a root method and filter scheme to further refine the profiling area. Okay, so let's take a look at exercise 1. So we are going to use Java 2D sample application that comes with a JDK. So it's actually provided under samples NetBeans directory of your hands-on lab. Okay, so you are going to open the project and Java 2D, and then you're going to profile. Okay, and here you are going to select CPU. Okay, and then you have two schemes, quick and advanced. So as we have talked about, quick is actually for sampled scheme and advanced is instrumented scheme. So again, if you take a look at the help screen, you find information about these things. Okay, in terms of filter, these are the filters you can choose. Okay, so in this case, for the sake of this exercise, we are going to profile all classes and see what's happening. Obviously, this is not typical approach you want to take because the overhead. So you can see the overhead is pretty big. Okay, and then let's run it. Okay, so when you run it, and you're gonna actually play around with this 2D sample application, arc curves, clipping, colors, and things like that. Okay, and then you can you can see the number of methods that are being in this case profiled or instrumented. So it's 1668, pretty large number of methods are being instrumented. Okay, and you can see a lot of system level, the classes are in fact being profiled as well. Okay, so if you click the live result, you can see where the CPU spending is time. Okay, and then you can actually stop profiling. Now 1.3, we are going to so we are going to actually use just root method, meaning we are going to use only a selected method instead of the the whole set of classes. Okay, so the two methods that we are going to select as root methods is inside rotator 3D Java. So if you go to Java 2D source packages and Java 2D demos and colors, okay, so there are in fact render method. Okay, so we are going to choose this render method as one of the two root method. Okay, so basically select render, and then you are going to select profiling and then add as a profiling root method. Okay, so we are adding this render method as a profiling root method. Okay, and then analyze performance. So basically we are going to click yes on this, okay on this. And another method that we want to add as root method is the step, I believe. Okay, step here. Okay, on the same class. Okay, and again doing the same thing. Add as a profiling root method, and in terms of configuration, analyze performance. Okay, and then we're going to start profiling. Okay, now if you take a look at the edit here, you can actually see the method that you chose as edit profiling root. So instead of actually selecting your root method from the source code, you can actually, when you do profile, you select this guy. Okay, so let's actually try this 2D. And when you say profile, and here, and then you can customize. And then you can expand this guy. So you can deselect all this guy, and then what we want to do is, let's see, which one was it? Uh, 2D demos and 2D demos colors. Okay, so 2D demo colors. So 2D. This one? No, not this one. Java 2D. Oh, okay. So 2D demos and then 2D demos colors. Okay, yeah. So yeah, we are going to select 2D demos and 2D demos colors, and then rotator 3D. Okay, and then you select the set of methods, and the one you want to add as root method is the step and render. Okay, and then okay. So basically you add two root method for CPU profiling. So you could do that as well here. Okay, so render and step. Okay, and then when you run the application, okay, and you play around with this application a bit, and then you can take a snapshot or a live result, and you can see only the methods that I selected as root methods, so render and step, those are only two methods that are being profiled. Okay, all right. Now in this case, we are selecting these two methods, but we also actually profiling system level Java code as well. So for example, random next, these are the things that we don't really care. So you can, in this case, select only project methods, project classes instead of all classes. Okay, all right. So this picture actually shows we selected root methods, but we are still instrumenting all classes that are being invoked within these two methods. But sometimes you don't want to actually profile, instrument those Java, the core level Java classes. Instead, you want to actually profile only Java 2D demos. These are the application classes. In that case, you might want to select, so profile only project classes or profile all classes. The picture in the lab documentation, we choose this guy, but you could actually choose only profile project classes. In that case, it's going to be even smaller. Okay, you're going to actually still see information about this, but the instrumentation will be done only project classes. Okay. Okay, so I'm going to give you guys about 15 minutes to do exercise 1. Okay. Next concept is profiling points. So you can set profiling points in your source code to more precisely control the collection of profiling results. So you can think of profiling points like a debugger breakpoints. When you do debug your source code, you can make debugger breakpoints, right? And you can think of profiling points behave pretty much the same as a debugger breakpoints. So you can actually trigger some actions when certain trigger conditions occur. Okay, so trigger conditions could be execution of a line of code. So when a particular line of code get executed, it will trigger something, and then you can choose trigger actions. The trigger actions could be create a heap dump at that point, reset the results collected, or run load generator script like JMeter script, or take results snapshot. So these are trigger actions that you can choose in any of the trigger conditions. So trigger conditions include execution of a line of code, time elapsed, or memory used. Okay, so you can actually have a combination of these trigger conditions for triggering these trigger actions. Okay. All right, so let's take a look at exercise 2. So we are going to use anagram sample application. I assume you guys already have anagram sample application, so you don't have to create one anymore. Okay. So what we want to do is we are going to insert 2 profiling points. Okay. So if you go to let's see, cancel this guy, and anagram. So if you go to source code and on the UI and anagrams. Okay, so initially it will actually give you a design view, okay, like this. Instead, you want to actually select the source, okay. So if you go down over here, there is the anagram constructor, okay, which is let's see, what is the 82, okay, 82. Here we go. Okay, so I have already created a profiling point. So you right click this guy, init components, and then select profiling, and then add as profiling root method. Okay, so I have already done that. Same thing for the last line of your constructor. So right click here, and again you select profiling, and then add as insert profiling point. Okay, so these 2 are added as a profiling points. Okay, now yeah, so each time you are going to actually add the profiling points, you are going to also select the action. So the first one, so if you take a look at this, I've already done this. So let me actually just remove this guy and start it again. Profiling. Okay, so how can I remove this guy? Okay, select this guy and reset, delete. Okay, and point, delete. Okay, so I'm gonna just start it again. So here init components, so that's the one I select, profiling point, and insert profiling point. And now these are the triggering actions that you can select. Okay, so what we want to do is we want to just measure. The idea is that we want to just measure this part. Okay, so by using a profiling points, you can even actually further down. You can actually narrow down within a single method. Okay, so we're gonna actually measure the performance of these lines of code. So that's the reason I select this guy, and then profiling and insert profiling point, and then we are going to reset result. So first we are going to reset result, and later on we are going to take the snapshot. Okay, so next, and finish. So now I have created the profiling point. When this line of code get executed, I want to reset result. Anything that has been collected up to that point will be resetted. And then the last line, I'm going to create profiling points again, add profiling points. This time I'm going to take the snapshot. Okay, and next, and finish. Okay, so we have 2 profiling points. Okay, all right. So now what we want to do is, now we are going to so we did that. Okay, and finish. Now we are going to start the profiling. Okay, so right click, profiling, and then advanced. So here, if you take a look at so if this is the one, use define points. So if you take a look at the show active profiling points, you are going to see those 2 profiling points that we have created. So let's actually try that. Here, right click, profile, and the CPU, and it's already selected for you because we have defined the profiling points. So if you want to take a look at the profiling points, you can see these are the 2 profiling points that we have created up to this point. Okay, and then run it. Okay, so this is a constructor. So this is going to be called just once each time, right? Okay, so it's actually starting the profiler, and we are going to see anagram sample application being displayed soon. Okay, so this is anagram application. So I'm going to just, guess, new word, and things like that. Okay. Now, you should be able to click this profiling points. Okay. So we have indication, we have X result. This one is hit once, and this one is hit once as well, because these are, the lines of code within a constructor. We should actually see just one hit. Okay. So you can take a look at this guy report. So this one is hit once, and the location of this, and this one. So this is basically reset result. So there is nothing much to see, right? But this one is a snapshot. So if you click the second profiling points, we should actually see the snapshot. It says the triggering action was take a snapshot. So we can just select open snapshot, and you can see where the CPU spent most of this time. So it's basically spend most of its time self time. So by the way, self time is any code within that particular the scope. Okay, and then when it calls another method, that's not going to be considered as a self time. So self time is basically whatever logic inside that particular the lines of code. Okay. All right. So that is profiling point. Okay, so I just showed you all this. Okay, and you can, okay, so you can take a look at the, so assuming this is the one that spent most of its time, you want to see where that code is, right? So I can just right click here and go to source. Okay, and so basically the init component. So this is init component. Yeah, so this is init component case. Okay. If you actually go to let's see, yeah, so if you select this guy, okay, so I select the self time, so that's the reason it's actually showing the init component. But if you go to over here, then okay, yeah, so this is the same thing. Sorry, yeah, go to source, and it should actually give you init component code here. Okay, yeah. All right, so I'm gonna give you guys about 10 minutes to try this exercise 2. Next topic is monitoring thread status. So you can get the threads timeline information from NetBeans profiler. So it basically displays the current and past status of all threads in an application. If you click one of those threads, it will give you thread details. So thread details give you detailed information about the selected threads, including list of all state changes in the thread life. Okay, so let's take a look at the picture of this. So these are threads timeline. Okay, so on this application we have these set of threads, and by the way, these colors will reflect the running application, running thread, and sleeping, and this one is wait, and this one is I cannot really see right now. Okay, so we're gonna take a look at this one in the end zone app. This is a thread detail. So when you click a particular thread, give you percentage of the time is spent on different state. Okay, so let's take a look at exercise 3. So here we are going to run Java SE application. Okay, so let me just show you this application and how it behaves, and then we are going to see how we can let me just stop the profiling and go to projects. This is the monitor threads application. Monitor threads. Okay, so let's run this Java SE application. Okay, so let's run this application and see how it behaves. So it's a Java SE GUI application. So now, this is the GUI application right here. Okay, now when I click start, okay, let's see what happens. Now, if I click exit, it doesn't respond. Even if I stretch things out, it's not stretching. It certainly does not respond to my, the user interactions, clicking exit or stretching things out. Okay. Now it will wait for 30 seconds, and once 30 seconds is passed, then it will behave correctly. Okay. So let's see. Yeah. So all right. So let me just move forward. Okay. So this is the behavior. After 30 seconds, it's fine. Okay. So now if you let's actually try to profile this guy. Okay, so now, yeah, so now I can, it's stretched out, it works fine, and then I can exit out. Okay, so let's try to profile this guy. So right click and profile, and we are going to monitor. So we're going to select the monitor and enable threads monitoring and sample threads states and run, and both of them should be set. Okay, and run it. Okay. And then, we're going to take a look at the threads. Okay, so here, once you click start, okay, what happens is that once we click start, which happens right here, there is a thread called the AWT event queue 0. This is the dispatcher thread, meaning this is the thread that handles user interaction. So for 30 seconds, this is actually in running state. Okay, which means it cannot use, this thread cannot be used for other interactions. Okay, as long as it's live, as long as it's running, it's not going to be available for user interaction events such as the clicking a exit button or the stretching things out. So obviously, this is not really a good way to use AWT event queue dispatcher thread. Okay. So that's basically what we are seeing here. The AWT event queue is in running state when you click the start. Okay. So we actually talk about these things. So if you take a look at the code, basically this is the code. Okay. If you take a look at display form Java, and if you go over here, break time, which is like 125, you can certainly find out, where it is actually spending most of its time by, profiling. Okay, assuming you do that. Okay, we actually, it's actually spending So it basically, we are spending time here. Okay, for 30 seconds. Okay, and this is in fact the dispatcher thread. Okay, so the way that you want to correct this problem is, you want to actually have a dispatcher thread to handle the request and then immediately release it. Meaning, you want to use the swing worker thread. Meaning, you want to use a separate thread for handling the actual the actual task. So what we want to do is we are going to comment this out, and then we are going to use the swing swing worker. So we are going to comment this out. Okay, so this is a badly behaving code, and instead we want to use a swing worker. So basically we are creating another thread that handles the actual task. Okay, so we are going to profile this guy. Now, let's actually see how it behaves. When you run the application, now, start it. Now we can exit out. It behaves as expected. And let's see whether we can stretch it as well. Okay, start, and we can stretch it as well. It works fine. Okay, because the actual stretch and actual task handling of this, whatever things that needs to be done will be delegated to another thread through the swing worker. Okay, so in this case, basically we are actually looking at whatever thread, and we can actually make a best judgment in terms of what's happening. So in this case, when you profile this guy, okay, you can see this dispatcher thread is going to just running very short period of time to handle the request, and then it's going to be back in wait state so that it will be handled the user interaction events. Okay. Okay, so usually you want to make sure this dispatcher thread is in wait state so that it is ready to handle whatever user interaction. Okay, instead of actually running state. Okay, all right. So okay, so I'm gonna give you guys about 5 to 10 minutes to do this exercise 3. Okay, so if you guys are done, please let me know. Next, we are going to see where the application spent its time the most, basically trying to figure out where the bottleneck is. Okay, So it can be set up to report only on particular methods or entire application. So we talked about this one before. So typically you do not want to instrument the entire application. Instead, you are going to select a set of methods for instrumentation. Graph categorizes where CPU time has been spent. So we have seen this example already. Basically you can actually see the percentage of CPU time spent on what method. Okay. You can drill down this graph to find out again more detail to get more detailed profiling information. Okay. You can also do load testing by starting JMeter script at the beginning of a profiling session. Alright, so this is the CPU profiling. Again, we have seen this picture before, right? So, this is basically, indicating for this method, it's actually spending almost like a 99% of the time, and then you can drill things down, right? Okay, so that's exercise 4. So exercise 4, this is a web application, and we would like to know, again, this is actually for creating a prime number. This is a web application. We'd like to know where it is actually spending the time most. In fact, we are going to actually run this application in both optimized mode and non-optimized mode. Okay, so let's see, compute prime number web application. So let's actually run this application first and see how it is actually behaving. Okay. So I click run application. It's going to run on Tomcat. Okay, and we are going to have a browser popping up. Okay, so we want to create the prime number of this 1, 2, 3, 4, 5, 6. Okay, so without optimized code, if you click submit, it takes about 1 second. And 498 milliseconds on my machine. So it might be different on your machine. Okay. Now, if you're using optimized version, it's using only 11 milliseconds. Okay. So obviously there is actually some problem in our unoptimized code, and we'd like to find out. Where that unoptimized code is located, and then we want to optimize it. Okay. So that's basically exercise 4. So we just run this application. We see the result. Okay. Now we are going to profile, so profile, and then we are going to CPU profile, and now here we are going to select the instrumentation, and we are going to select the root method. So if you click edit, okay, in this case this is a web application, so basically we are going to select process request method. So this is almost like pretty much like a top of the processing of your servlet. Okay, so we are going to select it as a root method. And then we are going to run the application. Okay, so then you're going to submit, and then we are going to see the most time it's actually spending is on this method, do count prime numbers. Okay, so that is the code that that needs to be optimized. Okay, so let's actually run that guy. Okay, so we are going to profile and CPU, and here you are going to select here servlet method. So you're going to just deselect everything, and then select process request, and OK, and then run. Okay, so it's going to start the application. It's going to display the page so that we can trigger the execution of prime number generation. Okay, so here we are going to use unoptimized version, so say submit. Okay, so then after 1 second and 634 milliseconds, so we can actually take a snapshot. Okay, so you can see the method that spends the most of its time is again calculate. So this is the method that needs to be optimized. Okay, so if you take a look at the code, go to source. This is the method that needs to optimize. In fact, it contains a very unoptimized code. Okay, so in calculate 2, that is actually optimized code. So if you go back to the lab documentation, so we just take a look at this one. Okay. So now when you call the so now stop it, and then when you profile, and this time we are going to use optimized the version of it. Okay. So in that case, it will use calculate 2, but it should not take more than the few milliseconds. Okay. Okay. So this time we are going to use optimized version, and it comes back right away, right? And again, if you take a look at the snapshot, and it's using calculate 2, and it's not bad. It's just using 11.6 milliseconds. Okay. So then uptime is this much. So you can see this is highly optimized than the calculate method we have seen before. Right? All right. So that is the exercise. So I am going to give you guys about. Oh, okay. So if you have time, you can do the homework. So you can just add. You can just plant this code into your 3D rotator 3.java, and you can actually CPU profiling and find out where it's actually spending most of his time, kind of things. Okay, so I'm going to give you guys about 12 minutes, and let's have 15 minutes break, and let's have just 10 minutes break. Okay, so we will be back at 2:40.